My name is Martin Andrews. I'm a Google developer expert, mainly because I helped found the TensorFlow meetup group here in Singapore. I'll talk a little bit about that later, but I also have a Red Dragon AI t-shirt on because that's what I do most of the time. So I've been a Google developer expert for machine learning since 2017. Google's been very generous. They kind of fly these experts around, but not during COVID. So we're looking forward to the end of COVID like everybody else. During the week, I do deep learning research and development, language and dialogue systems, generative models, and text-to-speech kind of things. So I do this during the day a lot. I also co-organize the Machine Learning Singapore meetup. So we renamed the TensorFlow meetup to being the Machine Learning Singapore meetup, and I'll explain why. You'll see why soon. Okay, so Red Dragon AI, we're a Google partner. We also do research. So this is one thing which keeps me up during the weekends. I write papers, we submit them to go to good conferences. Our latest product is a thing called these interactive digital personas, where basically you can interact with a live person who will talk back to you when you talk to it using a voice. There will be a dialogue system, interactive. So this is kind of, we do this in real time. We figure we're one of the very first people on Earth to do this. We're just rolling out this product, which we've been developing during COVID. Okay, so I've got three things to talk about today, one of which is called the Coral Micro Dev Board. So this is a small thing. The second thing is models for languages and other research at Google. These are enormous models. So this is kind of like where the research is. And the last thing is JAX and Flax, which is a kind of new machine learning stack, which in some ways you might think of as being a TensorFlow Keras or a PyTorch. This is a new entrant.
So let's try.
How about this? Okay. Right, so I'll talk about these three things. We're a little running late for time, so I'll keep the speed up, hopefully. So Coral is for on-device machine learning. So Coral is a little suite of these boards where the core GPU or TPU device was actually built by Google for their data centers. They produced a small version to fit in kind of a Raspberry Pi kind of setting. The problem that many people have with doing machine learning on the edge is power. You don't want to have you don't have like a very expensive GPU running all the time if you're trying to do a battery-powered device. So the way in which like a phone will deal with this, or a Google Assistant, is they'll have like a low power mode waiting for you to say, hey, Google, or Alexa, right? Just if there's anyone in YouTube, all these machines will be waking up, right? So these machines will wait for this word, wake up, and then they wake up other cores on the device to actually do the heavy-duty processing. So this has been something which is lacking in many of these kind of dev boards, the ability to target this kind of use case. So this is what's happening. So this dev board is kind of tiny. If we take my phone, so if we take 2 fingers from the top of my phone, I guess like this, that's the size of the board. So this is a small board, and it has two main things in it, one of which is a microprocessor with 2 levels of cores, the low power mode and the higher power mode, but it's also got this edge TPU device on it, which will do machine learning kind of applications super optimized for that. So if you go online and look for Coral Dev Micro Board, you'll find a nice video of this guy demonstrating waking up the device and also doing in real time his pose detection, all on a tiny board, which has a camera built in and a microphone built in. So this thing has a lot of capabilities straight away. So there's some various other details here, which I won't go through, but it's running good stuff. There's some Arduino compatibility built in. You'll also find that if you go on, they have an alliance with Asus, apparently, but if you go on Mouser, which is a component supplier, you'll find availability in some of these dev products, but others have long lead time. So this, if you're in the embedded space, you know all about this problem with the current semiconductor supply chain. And this is, I don't want to talk about pricing for this, because if you can't buy one, it doesn't really make any sense. Typically, other devices are in the range going from like 25 US for something which you can fit into an M2 slot to like 100 odd bucks for like more like a Raspberry Pi experience with running a whole bunch of stuff. So the competitor here, I guess, would be the NVIDIA Jetson kind of thing. They also have some other shields, but the question is, maybe you can buy a shield, but you can't buy the device. They have a plan for a whole product range, and it looks like they're building out the product range as we go. So this seems like an interesting ecosystem. To run it, it's basically a Linux environment you want to be running on your host machine. They say Windows and Mac support will be added later. Most people doing this kind of thing are Linux-based anyway, so I have an axe to grind there. I would definitely choose Linux anyway. Okay, so second topic, large language models and research. So this is stuff which is being done at Google. Let's just briefly describe, maybe I should ask, how many people have done anything at all with machine learning here? Oh, okay. So I talked to an Android developer earlier who said, well, I haven't done any machine learning. I've only used AutoML, which is really machine learning. How many, let's try again. How many people have done anything or done a course or anything with machine learning? Anything, some more, okay. People are embarrassed to admit it, but it's gonna take over, so you should be kind of with this. Okay, how many people have heard of the TensorFlow user group or just TensorFlow in general? TensorFlow, okay, we're okay. All right, so at least some people have got some grounding in what's going on. Let's explain what a language model is. Basically, a language model, I used to think that a language model would be just a model of how language works, kind of like a generic thing about language. But language modeling has a specific meaning, which is predict the next word. So here is it's not a very good, I have to say, not very good animation, but basically each time you come up with a new word, you suggest the next one, and then use that suggestion to build the next word, and the next, and the next. And these models are trained on huge amounts of text. And these models tend to be huge, as we'll see soon. So we've got a model on the left-hand side, which is LaMDA, which is one of the ones I'm going to talk about. And this has got 137 billion parameters. You've got GPT-3, which is OpenAI's one from a while back now, and that's 173 billion parameters. So this is kind of where the large starts. So I'm also going to talk about Palm, which has now got up to 540 billion parameters. And I should also point out these are dense networks. So if you're into machine learning, this is not a mixture of experts model. This is all of the weights have been learned all of the time. This is a massive model, or this is a range of massive models. So what happens as you start to expand the numbers of parameters is you start to go from something which has like a good grasp of what language is doing and can do some of these like fairly simple things and moves up to the summarization. But now once you get to these really big things, you can do things like joke understanding. So this is suddenly you get new capabilities coming out of these as the size of the models expands. So this is kind of exciting, but also kind of depressing if you're at home with your GPU, because there's no way that you can run one of these models yourself. Okay, so here's Palm. This is the paper which came out earlier this year. There's a lot of authors. These are all Google research people. Clearly that they're doing well in terms of the state-of-the-art results. This is beating all of the previous measures. And what we also find is as you increase the size of the model, not only does it get a little bit better, but it starts to actually curve upwards. It gets even better than you would think it would get better just by scaling. And so this is kind of an interesting thing, that the top line is a good human, the bottom line is like an average human. So in a lot of these domains, we're doing something quite interesting with these big language models. Now, I'm not going to claim that it actually understands language or it is actually doing reasoning, but by learning to repeat what other people will have done or statistically estimate what the answer would have been from the internet, these things can get really good at fooling people that this is actually understanding what is going on. So one of the other key points in the Palm paper is they also showed how it was trained, which is using over 6,000 TPU version 4 cores. These are like data center sized machines, or these pods are enormous things. And then like developers will know that the parallelization problem becomes a real issue. So you may have a very fast core, but if you can't pass the data around efficiently, then your whole model is going to be slow. So one of the key advantage here is more like an engineering test. Can we make this machine learn and keep the cores saturated while still reading text at a good rate? Okay, and the answer is yes, this thing learns and it's incredibly good. Okay, so what are they doing? What are they achieving with this? Okay, so what you'll have found with other smaller models is you'll have a base model and then you'll add a couple of layers to do what's called transfer learning. But what they found with these big models is you can actually get it to do it or do a task just by asking for the results in English. So let's have an example. Okay, so this is an irritating animation, but basically you ask it a question and you get it to give you the answer. So it's not that I have had to train anything again. It will just do essentially a really nice job of answering multiple choice questions, understanding cause and effect, all sorts of tricks with the English language can do this. Here's another one which is kind of unusual. People used to say, or they used to say that chess was the height of human thinking, and then it was Go. Now it's like, okay, can it explain a joke? Does it get sarcasm? Well, this thing can explain jokes. Well, in particular, it can explain like a nerdy Google joke about, anyway, I don't want to explain the joke myself, but basically Palm is taking the fun out of this joke, whatever fun was in the joke in the first place. Okay, another thing which you can do is, and this is kind of a discovery, and that people are not so much discovering like the machine learning mathematics things here. It's more like, how do we treat this model so that it will give us good answers? And so on the left, we've got standard prompting. So here's a kind of a word problem. Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? Right? And you answer, the prompt is, tell me the answer, kind of thing. And the problem is it will often make kind of errors. It's not a very good at this mental arithmetic and then coming up with the error in one step. On the other hand, on the right-hand side, there's a chain of thought prompting. You give an example of what kind of thing do you want me to tell you? And you actually say the kind of answer I want you to give is to explain your thinking and then give me a number. So if you prompt it on the kind of way on the right-hand side, you find that these models increase in their performance dramatically. If you give it the chance to kind of think about it out loud, it can give you the answer much, much more accurately. So it will go from like 15% right to 70% right. So this is kind of, and this is pure like text artifact. It's no special machine learning after you've built the model in the first place. Another thing we can do is it's seen enough of GitHub, seen enough of books about code that it can do translating code examples from one language to another. Or filling in the comments, all this kind of thing. So these models are incredible. Okay, let's move on to another. This is LaMDA. LaMDA is something which is designed for dialogue. So the Palm is designed just to be able to output text like the internet. LaMDA is designed to discuss things with you. And Google makes a big deal of this kind of conversational AI, and they've had a variety of papers from Mina to LaMDA, now LaMDA 2. So the LaMDA paper, which has now came out earlier this year, LaMDA is very chatty and it's very good at very good at talking about stuff. And they've kind of measured, like, the key measures for these things is to what extent is it talking about the truth? To what extent is it responding to your questions, right? So one issue is that when you train these models with dialogue, if whatever you question you just say, oh, I love you, a lot of people say, well, that's a great response. I love that response. But it's completely meaningless in the sense of what the conversation is about, right? On the other hand, you might just say, you might give an entirely truthful and factual response, but it doesn't flow with the conversation at all. So there's two kind of, you're battling two metrics in order to get good dialogue. And so they're trying to train this for some slightly different objectives than you would train the big language models to do the internet kind of thing. Dialogue is an interesting thing that humans do. Okay, so here we've got a bunch of other awesome authors. LaMDA 2 is now out. This is something which they talked about at I/O, but they haven't released the paper yet. This is probably even bigger, better training, all these kind of good things. But the thing which they promised, but as far as I can tell, haven't delivered yet, is this AI test kitchen. So the AI test kitchen has like 3 tasks, one of which is kind of imagine it, name a place, and LaMDA will start to describe it and offer you paths to explore it. So this is all, if you name a place, it will start to suggest like story paths. And you can then rate like how good is it, how interesting is this, all that kind of thing. So imagine it is one task. Another one is tell me about something. So this is not reading a blog post necessarily. Basically, this is essentially making up good lists of stuff on how-tos. So this is how do I make a vegan garden? It comes up with a summary of steps you do. This is all machine generated. It's like, this is insane what it can do. But on the other hand, it might go, I guess 2 years ago, you'd be very careful about releasing anything with this kind of generative text, because it might start abusing the users, it might start being racist or sexist or Nazi loving. You have no control about what it might say. On the other hand, now it's sufficiently fine-tuned that you know it's going to behave much more like a regular human. And so this is what they're releasing this bit by bit so that people can test it to see what the limits are. Because they know that if people want to destroy something, they'll find a way. And anyway, as Microsoft found out with their Tay chatbot. Okay, the last one is talk about it. So this is kind of on the subject, keeping on the subject. So they have a couple of editions, one of which is Dogs edition. This version of LaMDA wants to talk about dogs. And if you try and persuade it away from the subject of dogs, it will bring you back but it has to bring you back in a way that would go. It doesn't, if you say, I want to talk about Nazis, it will say, well, I don't know what kind of dogs Hitler preferred, but I love this. And so that's not a real example, but it basically will stop you deviating too far from what it wants, which is very much kind of the on target for real applications that like you might want in a business. Like a salesman is going to try and bring you back on topic. It's going to want to push the conversation forwards. That kind of directed behavior is very important for dialogue, because chit chat is all very well, but it doesn't make you buy anything, right? So it's not that useful a conversation as far as enterprises are concerned. Anyway, so this AI test kitchen is something which should be open to everybody eventually, but as far as I can tell, it's not open to very many people yet. There is a web address if you want to go and have a look. Okay, one other piece of research done at Google is in response to, you may have seen some models called DALL-E. DALL-E 2 is pretty good. Imagen is from Google, and Imagen is really good. In my opinion, this is better than the DALL-E 2 because it has a kind of engagingness which is difficult to put your finger on, but this has a kind of realism which is different from DALL-E 2. So one of the key points here is that it's, you put in a text prompt. So the thing at the bottom was generated by a human, and then it creates the image. So this image doesn't exist anywhere. It's just seen huge numbers of captioned images. And this is a photo of a corky dog riding a bike in Times Square, wearing sunglasses and beach hat. It has produced this pretty authentically. Now, one of the key things, and this is detail slide, one of the key things which it does, which is different from DALL-E 2, is that DALL-E, which is the OpenAI thing, has learnt the English language by reading captions. So all it knows about the English language is what people put in image captions, which gives it actually a fairly limited understanding of English. Whereas the Google version takes a pre-trained language model, like they've pre-trained a lot of them, like a Palm model, but a small version. And they use that, which kind of understands the text, and they use that to power this kind of distribution over the all images. So this is kind of a very interesting technique, proving out that the language itself is actually far more expressive than images are to some extent. You can learn a lot more about the world through language than images. It's kind of proving that out to some extent, which is an interesting kind of philosophical point. Anyway, onto the good pictures. So here we've got because it understands, in inverted commas, the language much better, it can actually do what's called compositional understanding, by which I mean that it can combine several different things and kind of keep them all isolated from each other to some extent. So here we've got, not only is it a picture of a raccoon, but it talks about how the light is entering the room to hit the picture of the raccoon. Whereas you might expect that the DALL-E image would be more about a raccoon with a light and a room. Basically, it doesn't have the same sophistication about the language. And so the DALL-E images will tend to combine stuff as a kind of collage, whereas these ones come out really nicely. And hopefully Google releases it so that people can have a play with it themselves. We know that DALL-E 2 is actually releasing it now to a much broader audience. I think their list has gone up. Over 100,000 people are allowed to play with DALL-E 2 now. You can also buy images to use commercially. So I'm not sure whether Google has incentives to do that, though, because Google, in some ways, is planting a flag that yes, they can do this perfectly, or brilliantly, but it's not clear what use case on a commercial basis Google has for this. Another nice thing which the Google ones can do is it will actually do very good writing. So what we find with the OpenAI ones is if you ask it to write a sign with words on, it will kind of get it right, but may make weird spelling choices. Basically, the writing aspect and the OCR kind of aspect is not there so much with the other models. So Google's one works great. I mean, it may not even know that that's what Google Brain is, which is like a department, but it's actually drawn a Google with a brain on top. It's insane what it can do. There's a marble statue of a koala DJ. It's clearly never seen, a lot of these test examples, it will have never seen on the internet. So it's clearly making up good examples here. Okay, so final topic, JAX and Flax. So if you've been, to do with the deep learning timeline here, I guess I arrived in Singapore in like 2014 or so. So basically, right when the early part was ending of the deep learning thing, I was originally working in Theano. And then came along what are now the major things with TensorFlow, PyTorch. I'm not sure I'm going to include Caffe myself, and now JAX, and then and Flax is now a new thing. So JAX has been around for a few years as a new framework developed at Google, but it's not really a Google project in the same sense that TensorFlow is. So TensorFlow has been a huge initiative at Google. And JAX was started off as much more of like an open source thing that people were playing around with on the side because they wanted to do research. But gradually this has got some momentum within Google and also outside Google. It's got some really nice kind of mathematical properties that researchers appreciate. So a lot of research is being done in PyTorch at the moment. There's definitely TensorFlow research being done, but PyTorch has taken over kind of the research mindset, and Google understands that when the researchers go, eventually machine learning will go, so that they're supporting this JAX effort. It has now become much more realistic to want to use JAX because it's matured. So what have we got? It was introduced in 2019. It kind of took off much more in last year. And so this is one reason which we renamed the TensorFlow user group, or the TensorFlow meetup in Singapore, which was probably Google's largest TensorFlow group in the world, which is pretty surprising for a small place like Singapore. We started that in 2017. We now have over 4,500 members. So we're quite a big meetup group. We await proper reopening so we can get back to actually having proper meetups. We're a technical meetup, so we expect code rather than marketing. Anyway, I digress. We renamed the TensorFlow group to the Machine Learning Singapore, partly because of the rise of PyTorch. It didn't make sense to confine ourselves to just TensorFlow, but also because of the rise of JAX, we want to be able to talk about JAX as well. So while we definitely love TensorFlow, we also love machine learning. So that's what the group has been renamed. Okay, so there's a statement here that says it's an open source framework. TensorFlow is open source in as much as you can see it on the internet on GitHub. On the other hand, that is more like a reflection of what Google is doing internally, and people are allowed to make suggestions in some sense. Whereas a real open source project is the community is building something and Google like helps them along, or Facebook helps them along. Facebook kind of stewards PyTorch. On the other hand, they don't like crush it all the time. It's not like I have to get, if I submitted a pull request into PyTorch, it might be that the actual authors of PyTorch would get back to me and say, oh, this looks super interesting, let's have a go. TensorFlow, apparently not so much, whereas JAX is like a proper open source project developed in conjunction with the community who are very active in making new stuff. And basically, JAX enables like NumPy, if you're familiar with Python, but it can put it onto CPU and GPU and TPU. And of all of those, probably the TPU piece is the most focused on by Google, because they use JAX to do all of these big language models, or they're using JAX internally. The TPU stuff is super optimized. Okay, so this is like NumPy on accelerators. You can also differentiate the whole thing, which means you can train models. So you can also export it. There's a whole bunch of nice interoperability things, and they're not trying to invent everything themselves. They're willing to work with other people, or they're very happy to work with other people. So here's I've got some little code examples. I think in the interest of time, I won't go through them, but basically this is one-to-one. NumPy on one side, JAX on the other, same code, same stuff. JAX will also do just-in-time compilation. So when you ask it to run code, it will dynamically compress the code, including Python functions and loops. It would do cool stuff to your code to execute it just in time. You can also say, I would like to have this, compile it now so I can use it later. And then you can actually compile up stuff as you go, super efficient and kind of really nice from a machine learning point of view. I mean, PyTorch will also do some just-in-time thing, but it's, JAX is really built for doing this explicitly, with parallelization, with multi-cores, all built in from the start. So on top of that, so on top of the basic kind of NumPy infrastructure, you've got this thing called Flax, which is like a neural networks library. And you can then use things like PyTorch or Keras kind of operations. And the base layer will be JAX with all of these nice features. I guess another thing which they wanted to do is make sure that you've got full reproducibility, so that if you have a model which is trained and then I train it again, I will have exactly the same model. So this is important for research, but it's also important from a engineering point of view. I want reproducibility. And in order to do that, has caused like huge mindset change within how you're going to want to build this. For instance, you've got to make sure every random number can be traced back to one seed. And so they'd be very careful with how you affect state, how you make functions side effectless. There's a whole bunch of nice programming concepts which they do here, which, because they enforce them, means that you can do a lot more compilation, a lot more reproducibility, all these good things. Okay, so this is why kind of research people are excited about JAX and the ecosystem, because it has these nice properties, which in some ways are theoretical, but actually there's some practical effects. Okay, so there's also a nicer API so that you can still do this functional approach. So a functional language has a purity about it, which is super nice. But you can also then use that just like you would PyTorch, which is a much more object-oriented kind of idea. So JAX is trying to do the right thing. They're making huge progress. That's why we renamed the TensorFlow user group, because we think that we want to be broader than TensorFlow. And if you're in machine learning, it's something to watch out for. I'm not sure I would suggest learning it as your first thing, but it's probably coming. Another thing to point out is that JAX enables lots of different components to be slotted in. So whereas PyTorch tends to try and have bits for everything all in one, the JAX thing, for instance, Optax is an optimization thing written by DeepMind. So this is within Google, this is a completely different place from regular Google, and these things will all play with each other nicely. Okay, so there's a nice page about getting started with Flax. Or come to our meetup group. We're sure to talk about these things, as well as just machine learning in general. Okay, so I've covered three things. One is the Coral Dev Build. I talked about the large language models, and also Imagen, which is cool corgi pictures, and JAX Flax as a new tech stack. So thank you very much. Let me just, right on time. We've got 2 minutes for questions. Okay. Well, so the question is, suppose we have a custom-oriented chatbot, how do we deal with emotions and all this kind of thing? Okay, so this isn't really a Google question from my point of view, because I have this, the Red Dragon's this product called personalabs.ai. You'll find a real-time interactive human chatbot thing. We don't like the idea of chatbot ourselves, but basically this can be integrated with a chatbot backend. So you'll see videos on there, but to understand it, we'd love to demonstrate it. Right? So how do you understand emotions? Well, the thing is, just like the previous speaker, that doing streaming of video, our chatbot thing or persona streams out to you, but also it has a camera, so you're streaming back to it. So in that sense, suppose the persona says, oh, please show me your ID for age verification. You can then hold up your ID and you say, can you hold it nearer your face? Because it can see, it can locate where is the ID, it can read the ID, and because it's a personable human, it gets rid of the flow of like upload a picture, all this kind of thing. It can ask you, well, what could you repeat yourself? So if regular chatbots, it will just say, I do not understand, please ask again. At which point I would typically give up, right? But if the human face says to you, oh, I didn't quite catch you, could you repeat again? You're very likely to say it. It's just the interactivity of humans is very different. So we're definitely working on this, but capturing what, like just looking at you, I can see that you're nodding. Probably you're understanding, we may not be agreeing, I don't know, but there's some kinds of emotions which I can capture. Some of the body language, you can see some listening or smiling if you're surprised by an answer, right? So, but basically I can do some kind of emotion recognition, and just understand via the latency of your responses, to what extent are you on board with what I'm saying? So this is an area which is, we figure, so my co-founder and I figure that this is going to be a big deal because humans can do this, but a digital human will never need to sleep. It will never swear at a customer. It will not be ill, right? So there's a whole bunch of interesting things to be done here. And this is just starting, but it could be huge because it extends to all of human interactions. So we were very interested. Okay, I didn't plan this question, but it's like, awesome question. Okay, you've been nodding most.
Thank you. So you talked about Imagen, right? So Imagen has implemented language processing in their prompt
Right.
recognition. So do you think it would be more expressive, and a model could be more expressive if they implement emotion recognition as well?
Okay, so the question is, what if you have for Imagen, which recognizes the initial prompt, what if you have some kind of emotion recognition in the prompt?
Let's say the person is saying something to the model and they recognize the emotion of the audio or the person's face.
Right. In research terms, emotion recognition from audio is already a thing. Also, emotion recognition from text is definitely a thing, because sentiment analysis is a well-trodden path. On the other hand, if you have one of these large language models, you wouldn't necessarily have to train a big emotion recognition thing at the top. You would just say, after you hear this text, is the person happy or sad? Is the person angry or amused? And it would then know the answer. So having these big language models has some consequences. So I haven't quite answered your question, but I'm definitely happy to talk about this. But having one of these big language models seems to be a much better foundation than just learning from captions alone, the captions may not have a lot of context in them. So
yeah, that's my point. But because having the same caption, like same text, you can say it in two different tones.
So there's a famous, so they're saying having the same text, you can have it in various different ways. That's one aspect. But also, if you have a single picture, but you caption it, this is an angry person and this is an amazed person, people will take both of those captions equally. The images themselves can be ambiguous as well. So there's a bunch of different things to unpack. I understand.
No. Okay, what you are taking is the emotion in the prompt. I am saying the emotion of the person giving the prompt.
Okay, so there we could use the video frames coming in to actually see their face. That's definitely something which is, I would say, a nascent research field. To actually identify someone's emotions, in particular, some people may have a good poker face, difficult to do this. You also have to be very careful about bias. So some people will have different gestures or different expressions for looking quizzical or unsure or skeptical. So detecting these emotions is very contextual. On the other hand, the payoff for being able to do it is enormous. Salespeople are paid to have that kind of emotional intelligence. So there's a lot there still to be done. So there's another question over. Okay, so the question here was, there is super exciting to hear about the huge models, but is there stuff about smaller models? I particularly like the idea of smaller models, just because I would like to be able to contribute to the bleeding edge. I guess one thing to point to is DeepMind had a model called Retro. And what Retro did, and this is published around December, it was using retrieval. So it had a model which was understanding the language coming in, but then it would look up in a database to try and figure out what else to say. So the database essentially was like 1 trillion tokens or some very large number of tokens, but really that's just one hard disk full, because you don't need the GPU to focus on those trillion-sized tokens. You can do a fairly simple database kind of lookup. or a vector kind of lookup on those. And so the neat thing about the retro model is it proved to be very, very capable, but it used a fairly small model coupled with a hard disk worth of data. And the fairly small model is more like 8 billion parameters. So that's something where you can begin to, in the next generation of GPUs, you could possibly have that inside a GPU. Like a 3090, you'd have a chance of being able to process that. So these, in some ways, it's interesting. It used to be that people just thought that the bigger models would be the forefront of research forever. But now people are realizing that just proving that it can be done, if you then distill them back down to a small model, you can actually do really well with a small model. But maybe you need the capability of a huge model to process the stuff in the first place. But once it's got the idea, the small model can do really well. And so this is, we even published research on this for when a big model was 300 million parameters rather than 300 billion parameters. Basically, you can take one of the BERT models and then compress out a tiny language model or tiny sentiment analysis model, which you could then even run on a phone or on a Coral device. So once you've got something which has kind of condensed in the details of human language, it's got really good intuitions, which you can then hand to a student model as its teacher. Anyway, so there is hope for people with smaller machines, though the excitement was with these big models. Okay, so thank you very much indeed. Thank you.